So we're moving on from just using knowing our sine, cosine, tangent, and now we're going to actively use them to solve for triangles. And specifically, we are going to solve for right triangles. Okay, we're solving for right triangles, and that's how we start. And as we work on our skills with solving for right triangles, we're going to break out and solve for any type of triangle. Okay, and there's some requirements that we need to have to solve for these right triangles. And the thing is, you need to know. So we need to know 3 things about each triangle. So in order to solve for any triangle, we need to know at least 3 bits of information. Now let's draw the triangle in general. And a triangle consists of a side, side, and side, as well as an angle, angle, angle. Turns out there are 3 sides and 3 angles. And that's a characteristic of any triangle. Triangles are only made up of 3 sides and 3 angles. That's all we can say. How long is each side? What is the turn? What is the degree of each angle? And that's it. Once we have those things, we've discovered everything we need to know about the triangle. A lot less deeper than human beings. So what we're going to do here, let's go ahead and look at a simple example of something that we know already. So that's a special triangle, 30, 60, 90 triangles. So if I draw your 30, 60, 90 triangle, I can just give you a hint that this is a right angle, this is 1, and the angle 60. I gave you 3 bits of information. Let's figure out what the rest of the stuff we need. As you can see, I gave you, and 90 degrees is an angle. That's an angle. That's an angle. 60 degrees is an angle. And we're given a side 1. So I gave you guys pretty much half the information. And in this case, if you give me 3 bits of information, that's enough to dox you. You guys heard of what docking someone means? It's exposing them to the world of who they are, where they live, what's their phone number. So we're going to dox this triangle. Now, since we've seen this triangle before, 90 and 60, what do you think my third angle is going to be? All angles add up to 180. So if I say 180 minus 60 minus 90, we are left with 30 degrees. Oftentimes, since it's a right triangle, this is actually faster. If I say 180 minus 90, we are left with 90 degrees, right? So 90 minus the 60 gives me my 30. That's a lot easier to think about. If I know that this is 90 degrees, we have 90 degrees left to share. So if one angle is 60, the other one must be what's ever left over, which is going to be 30 for us. So we now know this is 30 degrees. Hey, we've seen this triangle already. This triangle is a special triangle to us. It's a 1, 2 squared to 3 triangle, so the hypotenuse is double the short leg. That's going to be 2. And the long side is going to be square root of 3. Now on the flip side, what if I only gave you 2 bits of information? What if I only give you 2 bits of information? Would this be enough for us to discover what the rest would be? And the answer is not enough information. You need at least 3 bits of information to make this work. And why do I say that? Is because, hey, what's the difference between this triangle and this triangle? This is still a right angle, and this is still square root of 3. But this angle here is now different. One's a bigger angle. So we need to know at least 3 bits of information to trap this triangle down, to make it get stuck in a certain shape. And you've actually seen these back in geometry, if you remember them. There's, for instance, SSS. Whoops, I don't know, a SSS were 3 sides congruent triangle theorems. There was SAS. There was ASA. There was one more. There was which one was it? I forgot. Anyways, the ones that don't work. So these are ones that work. The ones that don't work were AAA, AAA. That's an auto car service. That is not a triangle congruence property. And ASS. That's that one didn't work either. So no cousin. Curtis, what's your question?
Uh, Two. Wasn't there also SAA?
S SAA. Yeah, that was the other one I was missing. Thank you.
And
I
then
I I'd forgotten it. What's what?
and the second one was because I have PTSD for this. There's not going to be proofs in calc, is there?
No. Well, not this part. We're going to use identities to prove theorems, certain things, but not like in geometry. No, not like in
Okay.
geometry.
Okay. Thank you.
Of course. Okay, let me record again.